All right, let's get this underway. So maybe you want to present your slides, Yifan, and let's get started. What do you have for us? Let's talk about colocation.
Yeah, sure. Okay, so today it's my pleasure to introduce our feature colocation to you guys. Yeah, let's get started. First of all, this is today's agenda. First, I will talk about YugabyteDB regular table sharding mechanism, what is colocation, benefits of colocation, several use cases for colocation. Finally, I will do a live demo and talk about future development plan. So, YugabyteDB is horizontally scalable by design. So basically, in YugabyteDB, we usually split the table into smaller units called tablets, and each tablet is essentially a group of rows of one table, and each tablet forms a wrapped group. And the horizontal sharding is 100% transparent to the user, and is a key part for application to scale its workload. Currently, YugabyteDB supports both hash and range partition. And this graph just illustrates the idea. A use table is divided into several small pieces of tablets.
Okay, and each of those things is called a tablet, right? If I'm not wrong.
Yeah. Yes.
Yeah, and this is just kind of transparent to the user. So you create a table, it can get split and it can move around, right? Okay.
Yeah.
So this looks good. So
yeah, exactly.
What's the issue? Yeah.
and each tablet forms a wrapped group and backed by several DB instances. Okay. Let's keep going. But this may not always be ideal. Imagine a scenario. There are lots of small tables in a database, and by the default horizontal sharding, each table needs at least one tablet. Then a cluster with many small tables will end up having too many tablets. And actually, there's a limitation to the number of tablets one YugabyteDB cluster can handle, because each tablet introduces actual network, disk, and memory overhead. And we also need actual metadata to track tablets for each table's index, etc. Also, it could have higher latency when dealing with a sharded tablet, because for queries, sometimes we need to send multiple RPCs to several tablets of a table, which adds latency.
Yeah, totally makes sense.
Yeah. So yeah, let's enter the collocated database world / colocation world. So basically, colocation is a database level concept. To use colocation, you have to first create a database, a collocated database. And with the colocation, you can actually put multiple relations into a single tablet called collocated tablet. And all relations that are collocated are backed by the same RocksDB instances and use a single wrapped group for replication. And this graph just illustrates the idea. So basically, there are hundreds of tables with different schema reside in the same collocated tablets.
Yeah, makes sense. So going back to this, so what we're saying here is, suppose I have a database which has 100 tablets. I mean, 100 isn't too much, but let's say I do have 100 tablets or 1,000 tablets, tables. What would happen without colocation is there would be a minimum of 1,000 tablets, each with their own RPCs, and you'd get all of that overhead that you were talking about and the issues that you're talking about on the previous slide. And they may not all be big, and let's assume all of them are small, then you can pack them this way, and the entire database is collocated, and you can have everything residing, and you can minimize the network transfers, all of that stuff. Is that the right idea?
Yeah, that's 100% correct.
Got it. Makes total sense. Okay. So yeah, go on. Just tell us about the advantages of this.
Yeah, so generally speaking, there are three big advantages of colocation. First one, as we mentioned, we can support a large number of relations in a collocated database because many tables share the same tablets, consume less disk memory and network overhead. And secondly, we can actually optimize certain query execution to not require actual RPCs. Let's take secondary indexes, one example. So regularly, for non-collocated table, i.e. table with several tablets. So we would perform like secondary index scan is first we issue several RPCs to the secondary index of one table to retrieve row IDs from the index. And then we issue another group of RPCs using these retrieved row IDs to read data, corresponding rows from the base table itself. So actually that's like 2 rounds of RPC. However, with collocation, since collocated table and its index are collocated on the same collocation tablet, then actually we only need one round of RPC. We issue one RPC, a read RPC. We first retrieve the row ID from the collocated index, and then we find out the table and actually and its index actually collocated on the same tablet, and then we can directly do a local read to directly read the data from the base table itself. So this actually help us reduce like network hops to speed up the query execution for secondary index scan. And finally, collocation is also good for multi-tenancy use cases. Imagine there are many databases in one cluster. Collocation will fit well for this case.
Yeah, makes sense. And I think for those of the people wondering, like the first point, right? Like you can support a large number of relations, right? Like is for people wondering just how many relations is a large number of relations. We've actually had real world workloads that need more than 50,000 relations in a single database. So more than 50,000 tables and indexes and views and so on and so forth. So collocation does come in quite handy in a bunch of places. But
yeah, exactly. I did some testing with like 600,000 tables, and that works fine.
Oh wow, fantastic! Of course, it depends on the machine size, a lot of details,
yeah.
But that's great to know. All right, cool. I think Surendra has a question about where we use YugabyteDB. Surendra, just a real quick thing. YugabyteDB is a transactional database. It's Postgres compatible. So what we're talking about is but it is cloud native, which means you can survive. You can replicate data, survive failures, do transactions, use all of your Postgres features, but yet scale out horizontally and upgrade and so on. So you should perhaps look at our documentation to get a better idea. Venkata asks, how are the rows from different tables laid out inside the same tablet? So Venkata, please hold that question. I will ask it again once we're closer to a demo, but that's a great question.
Yeah, that's a really great question.
Yeah, so Jim nicely asks, can you explain how the single tablet of a collocated table is replicated? RF equals 3.
Yes, so that's replication. It's kind of straightforward. So basically, we have like a Raft group for this whole collocation tablet. And even under like RF3 situation, there's only one single tablet.
Yeah, I think perhaps the two questions are related. So we'll come to both of them in a little bit. Okay, let's keep going. Let's do this. And closer to where we do the demo, I think we'll explain both of those in one shot.
Yeah, sure.
Okay.
So, but in weights, what about there several big tables in one database? How can we handle this in a collocated database? Imagine a scenario: there are 100 relations in one database. 99 of them are small size tables. So in this case, we can put all these small size tables into one tablet. And what about the remaining one big table? We can do the horizontal sharding on this big table to shard it into several tablets to scale its workloads. And this graph illustrates ideas. Shard one table into several tablets, and all the remaining small tables, just fit in one tablet.
Yeah, makes total sense. And each of these tablets is replicated using Raft, so it's all a replicated, highly available system. Yeah. Okay.
Yes.
Yeah. Let's keep going.
Okay, so let's talk about use cases for collocation. So actually, collocation can be applied to many scenarios. In general, there are 3 big chunks of use cases. Some of them I actually briefly covered in previous slide, but anyway, let's do a recap. First, if one application needs a large number of tables and the index is in a single database. And the application needs high availability and a geographical data distribution, then we can just use colocation to put all these small size tables into the colocation tablets. Secondly, imagine a scenario that one application needs a large number of relations, and the rest of tables will continue to remain small, but only a few large tables I expect to grow as the application runs. So in this case, we can put all these small size tables into colocation and only sharded large tables into tablets to scale its workload. And finally, in micro services-oriented architecture, each microservices needs its own database. And each of these databases is small, but the number of databases can grow rapidly as the number of microservices grows. That we can put all tables of each database into the colocation tablets, so we can scale the number of database in a YugabyteDB cluster.
Yeah, makes total sense. So Luis asks a question, which is a pretty good one. What is the criteria in terms of size to decide whether or not we want to collocate the table?
Yeah, that's a really good question. So generally speaking, I think I kind of forgot the number, but I guess table size below like 100 megabytes are considered like small table.
Yeah, I think the reality here, Luis, is also it depends on the size of the machine and the type of access, a few different things, right? So let's take a few examples, right? Like as Yifan said, if you have a table that's under 100 megabytes and it's used in a certain number of queries, not too many queries, then sure, you should definitely collocate it. If the same table is now accessed a lot, right, like through a lot of IOPS, then you probably don't want to collocate. You want to pull it out and split it, right? Now, on the other end, if you have a big beefy machine, and even if your tables or your database size is say 50 gigabytes, right, or let's say 10 gigabytes, 20 gigabytes, 50 gigabytes, you probably can collocate it. It's also a little bit dependent on what the size of your machine is, what the total number of IOPS you have, so on and so forth. I think it's important to think through the nature of your application. Does it need low latency when you're doing these various operations? As in, does the network get in the way of your latency, or are your accesses such that you're not incurring the network latencies? Because if you're doing, say, more complex joins, as Yifan was talking about, the secondary index scan, if you're doing a bunch of those type of operations and you want low latency, then distributing over the network would be a disadvantage. But if you go the other way and you're saying I'm not doing too many of those accesses, I'm doing simpler lookups, but I really need the scale and the ability to pool across different machines, then you don't need collocated. The reality is, it's not like one application or database is one way or the other. It's really it's both coexist inside the same application. There are a bunch of tables that you will want to do quick joins and lookups on, and a bunch of other tables that are high scale, high throughput, and you want to pool. So it really depends on that. Typically, if you need scale, you don't collocate. If you don't need scale, but you need latency and performance, you do collocate, right? And you have to figure out the boundaries inside your application. Obviously, over time, we want to make this more automatic. The database can split, but right now, it is something you'll have to think through. Yes, and I think Jim shared a doc. Thank you for sharing the doc. So, okay, let's keep going.
Yeah. One thing I want to add is, currently, although we don't have like automatic decollocation feature, but at one stage, at one time, you just find out, okay, I want to pull this one table out of collocation, then you can just use create table and select a statement to somehow simulate the process.
That's right. As you discover tables that need scale, you can pull them off, right?
Yep. All right. Yeah, before diving into the demo, let me briefly talk about the colocation syntax. Again, colocation is a database level concept. So if you want to use colocation, you first need to create a collocated database. So it's simple, just use the colocation option inside the create table statement. And if we want to create a collocated or non-collocated table within a collocated database, then you can just specify collocation option again inside the create table statement. And inside and within a collocated database, we collocate any table by default. So if you want out of collocation, you must specify collocation equal to false in your create table statement.
Yeah, makes sense.
Okay.
So if you say at the database level it's true, it means all the tables you create will get collocated. You have to then say false for what you don't want. And if you say it the other way, then you have to say true in order to put them into the group, right? You give both sides.
Yeah, exactly.
Got it. Yeah, got it.
All right. Then I guess it's time for demo.
Yeah, let's do the demo. And then
Right.
we can talk about some other questions that folks
Okay. Okay, sweet. Okay, let me share my screen. Okay, so let's first connect to YugabyteDB, because I want to create a collocated database. And then let's connect to this collocated database. Let's create a server table. Table 2, another collocated table. This time I will use the option. And then let's create 2 more non-collocated tables. Okay, then let's insert some data into this table.
So this is into the collocated table, right? Yeah, the first one.
Yep. It's like 100K rows into each table.
Yep.
Same thing for other tables.
Okay, I really have to commend your fluency in Postgres, man, Yifan. If I had to do that, it'll take me like at least 10 minutes of searching Google, that generate series thing. I know what it is, but I can never get the syntax right. So fantastic.
Oh, yeah. Thanks for the compliment. Actually, I use it every day. Yeah.
Okay. You're typing live too, which is awesome. Yeah.
Okay. Let's actually before do like.
Do you want to turn timing on just so you're able to see it?
Let's turn timing on.
Okay.
Okay, let's try some pre-execution first. First secondary index pair, this comment.
Yeah.
Split pair, analyze, response, select people where. Oh, actually, one second. I need to create like several index to use second index.
That's right. That's right.
Table.
Table, you mean? Oh, yeah, that's table. Yeah, you're right.
Okay. Yeah. And also create an index on non-collocated tables.
Yeah. So one index on collocated, one index on non-collocated. Yeah.
Yeah, and then we want to compare.
Building the index. Oh, this is building and all that stuff, right? It's building the index in the background. Got it.
Yes.
So.
Yeah, actually, I guess since we have data, so it's the index build.
Yeah, and I think even from the index build time, it's clear that collocated is faster, right? 6 seconds versus 14 seconds.
All right, so secondary index scan, it takes like around like 60 milliseconds for a collocated table, and then let's see how this goes for non-collocated table. Okay, it's like 300 milliseconds.
Got it. So to explain what just happened, so in the collocated case, there's one tablet which contains the table and its index, right? And you're going to that tablet and you are picking up all the rows that have value equal to 6, and then you're looking up the values equal to 6 all on the same tablet, right? So there's no distributed IO. But in the other table, you are, you go to like a set of tablets or maybe one tablet to look up value equals to 6 to the index table, and you'll get, say, a bunch of rows, say 10 rows or something. And then you'll go to perhaps multiple tablets in order to fetch them.
Yes, exactly. Even, somehow we were lucky, all the data fit on one tablet. It's still like worse for
And as the table gets bigger now, what would happen is in the collocated case, it won't fit at all because it's getting too big. And in the other case, even if the latency is a little higher, you will actually get it to work.
Exactly.
Got it. Yeah, makes total sense. Yeah, makes total sense. So what else did you have in this demo? Because there's a question that I'd like you to try on the fly, but we'll see. We'll come to that.
Yeah, we will come to that later. And actually, we can do something like a nested loop join.
Yeah.
Do some join, again, explain, analyze, cross off, select table 2 where table 1 is P, and table 1 value equals to 6. I guess, okay, let me tell some, optimization we have to speed up the process.
That's absolutely, this was covered in a different YFTT, if folks remember.
Yes, okay, now, it's actually a speed up the nested loop join.
Yeah, nested loop join, where the operations are done in batch.
Yes, and then let's try the same thing for non-collocated and see how it goes. Yeah, still takes much longer time.
75 milliseconds versus 640, right? About 10x or 89x, whatever slower.
Yeah.
Makes total sense. Yeah, same fundamental principle. Yeah. So okay, what else did you have for us?
Yeah, and actually, I want to introduce some utility function. For example, there's one function called YB. It's database collocated. This function can tell you whether you're within a collocated database or not. Awesome. And also, if you use like Postgres describe command, describe one table, you can tell, okay, a table is collocated or not based on the footer.
Fantastic.
Yeah, just virus utility functions.
Okay, so now maybe let's go over the questions that folks have.
Yes.
So one thing that would be good to do is Louise had asked, can you elaborate more multi-tenancy? Does that mean we can have the same table in multiple collocations? Can we target? I think so. It's good to explain that. So what we did is we have created one collocated database with 2 tables in one tablet, the collocated tablet, which is TBL and TBL2. And we created 2 tables that are sharded, TBL3, TBL4, right? Now, can we create another database that's collocated? And then we can create some other tables there just to show. And that other database can have the same schema or the different schema, right?
Yeah, exactly.
So, yeah. Okay, so this is a second database that we're creating, and we are going to create the same schema here.
Oh, we want the same schema?
Yeah, why not? Will it work?
Yeah, it definitely works. So actually, any schema you want.
Yeah, no, but let's just do the same. So you could have multi-tenancy where you have 2 different databases, or you would have multi-tenancy where you have the 2 same databases. It doesn't matter.
Yeah, it doesn't matter. Yeah, again, 2 collocated table.
Yeah. Okay. So that's good enough. I think that illustrates the point, right? Like now we can describe this and you can describe that. So okay. So that answers that. I think let's go back to the question, right? How are the rows from different tables laid out inside the same tablet, asked by Venkata?
Is this question referring to like collocated table or not?
Yes. It's referring to a collocated, yes.
So basically, so let me dive into some technical depths for this question.
Yeah.
So basically, all the collocated tables, they are, their data is put into the same RocksDB instances. So actually, we have like a prefix to unique identify. Okay, which row belongs to which collocated tables, and that prefix is called collocation ID internally.
Got it. So basically, you have one shell table or a parent table for the collocated database or something like that, which has the tablet. And inside that tablet, you lay out the rows in such a way that it's prefixed at perhaps the row key level with the collocation ID, which is really the table ID, and you do the mapping, something like that.
Yeah, something like that.
So hopefully that answers your question, Venkata. And to continue on Jim's follow-up question, which is, can you explain how the single tablet of a collocated table is replicated? So what goes into the raft payload when it gets replicated? So we have this tablet where you have all the user-defined columns, but you have an internal hidden first column, which is like the collocated tablet table ID, right? Like, so that's the way it's laid out in the tablet. How does it get replicated? Does the same thing get replicated?
Yes. I think like how it replicates its data or like the schema.
The data, I think the data is probably what it is.
Okay,
so if I write a row to one table and I write a row to another table, how does that get replicated?
Okay, so basically it's kind of similar or exactly the same as the regular non-collocated tables. So basically, we just need actual when we replicate it, just append or pre-append the actual collocation ID and do the normal router operation replication.
Yep. So basically, it's just like any other tablet. Yeah, just like any other tablet, Jim, and the collocation ID just flows through, and that's it. So we don't treat it any differently. So Piet says, good presentation, good demo, Yifan. So thank you for that. Thank you, Piet. But one question he had is, can you use explain or another method to prove that the difference in timing is actually due to collocation and not coincidences or other things? Like, is there a way to look at what happens inside or in the background? So does it show you?
Definitely. Yes. Definitely.
You probably want to go back to the other database. Like
my bad. Actually, for example, let's go back to secondary index again. Oh, my bad. Actually, in this case, we can slightly change this, like explain, to use like this operation.
So this is a new thing that we put, which is
I guess it's make more sense for Joy. Let's let's see Joy. Okay, so for collocated case, sorry, my bad. I have to set the fetch necessary loop again because it's fetch variable.
Yeah, this feature is not yet fully released, so you got to do that manually right now. But it will become default at some point.
Yes. Okay. So
and I think also very interesting is the fact that we have this distributed explanation for what happens inside an explain. So it's a recent enhancement where it actually tells you what's going on in a more distributed way.
Yes, and let's see how it compares with non-collocated case.
Okay.
So as you can see here, we have more storage read for non-collocated table case, and for collocated table, we only have like 10 storage read.
Yep. So
but for non-collocated case, you have like more.
Yeah, there's 10 reads against the index and 10 reads against the table because they can all be sharded. And in the other case, there's only 10 read requests against the table and one against the index because it's just a single lookup on the index, right? Of course, this can get even further optimized because we know that the table is also collocated, but those are the enhancements that are going on internally, right?
Yes.
Okay, so hopefully that answers your question yet. Other questions, folks? I think we're at time actually. So, so what's next? Maybe just round it out with what's coming next, Yifan, in colocation. It's pretty exciting.
Yeah, sure.
It actually blends, I think, how a traditional database works with how a distributed database works. So it's super exciting from that perspective.
Yes. Okay. Maybe let me reshare my screen to my large slides. Okay. So what's next? So in terms of like future development plan, we actually wanted to develop the feature to do decolocation automatically, to automatically shard fast growing tables when it sites beyond some threshold in a collocated database. And secondly, we want to support table space plus collocations. Basically, table space is another YFTT Yugabyte features. It defines the customized placement policy for a table.
Like
So-
multi-zone, multi-region, all of that stuff at a per
Yes.
table or per table space level. Yeah, makes sense. Yeah.
Yes, I think we also have a talk for this. So definitely, if
Yes.
you guys are interested, what's that?
Yeah.
So table space collocation just give us the ability to define a customized placement policy for collocation tablet, and also we want to further improve performance when query processing happens with data collocated on the same node. That's what I just demoed.
Fantastic. Yeah, and this is obviously a continuum, right? We just keep improvements we can keep making over time and keep getting better and better. Awesome.
Mm-hmm.
Fantastic. So thank you, Yifan. This was really, really good and an excellent demo. So thank you. Thank you, folks, for joining us as always. We'll have another YFTT next week, same place, same time. In the meanwhile, any questions, once again, drop it on the LinkedIn comment box. Join our community Slack is shown there, yugabyte.com/Slack. And go to the YFTT channel. We'll be looking at it. And yeah, thanks all for attending.
Yeah, thank you guys. Join us on Slack, start us on GitHub.
Yeah, absolutely. Do star us on GitHub.